Let's work through this problem carefully and see whether the area of the triangle can actually be determined uniquely. We are told that we have a right triangle. One of its legs is exactly 12 units long, and all three side lengths are positive whole numbers. Our goal is to find the area, but before we do anything, take a moment and see if you can predict whether there will be only one possible answer or more than one. Now, let's assign some variables. We'll let one leg be 12. We'll call the other leg x, and we'll call the hypotenuse y. Since this is a right triangle, we can use the Pythagorean Theorem, which tells us that the square of the hypotenuse equals the sum of the squares of the two legs. So we can write 12 squared plus x squared equals y squared. 12 squared is 144, so the equation becomes 144 plus x squared equals y squared. Now let's move x squared to the other side. That gives us 144 equals y squared minus x squared. Notice what appears on the right side. We have a difference of squares, and whenever we see y squared minus x squared, we can factor it as the quantity y plus x multiplied by the quantity y minus x. So now we have the quantity y plus x multiplied by the quantity y minus x equals 144. This is the key step of the entire problem. Since x and y are positive whole numbers, both factors must also be positive whole numbers. Let's now list the positive factor pairs of 144. We have 1 and 144, 2 and 72, 3 and 48, 4 and 36, 6 and 24, 8 and 18, 9 and 16, and 12 and 12. Now we're going to test these pairs one at a time. First, suppose y plus x equals 144 and y minus x equals 1. Let's add the two equations together. Notice what happens here. Positive x and negative x cancel, leaving us with 2y equals 145. Dividing by 2 gives y equals 72.5. That is not a whole number, so this factor pair cannot work because the problem requires integer side lengths. Now, let's try the next pair. Let y plus x equal 72 and y minus x equal 2. Again, add the equations. The x terms cancel and we get 2y equals 74. Dividing by 2 gives y equals 37. Now substitute that value into y minus x equals 2. We get 37 minus x equals 2, so x equals 35. That gives us a triangle with side lengths 12, 35, and 37. Let's verify it quickly. 12 squared is 144. 35 squared is 1,225, and adding those gives 1,369. 37 squared is also 1,369, so this is a valid right triangle. If you're following along and enjoying this logical process, don't forget to like the video, subscribe to the channel, and comment below whether you expected multiple solutions before we finish. Now let's continue, because we cannot stop after finding just one valid triangle. Next, let's use the factor pair 24 and 6. Let y plus x equal 24 and y minus x equals 6. Adding these equations gives 2y equals 30. Dividing by 2 gives y equals 15. Now substitute that into y minus x equals 6. We get 15 minus x equals 6, which means x equals 9. And this produces another right triangle with side lengths 9, 12, and 15. Let's check it. 9 squared is 81. 12 squared is 144, and 81 plus 144 equals 225. 15 squared is also 225, so this triangle works perfectly as well. But we're still not done. Let's test another factor pair. Suppose y plus x equals 18 and y minus x equals 8. Adding these equations gives 2y equals 26, so y equals 13. Substituting back into y minus x equals 8 gives 13 minus x equals 8, which means x equals 5. That gives us a third right triangle with side lengths 5, 12, and 13. Let's verify it. 5 squared is 25, 12 squared is 144, and 25 plus 144 equals 169. 13 squared is also 169, so this is another valid solution. Finally, let's look at the factor pair 12 and 12. If y plus x equals 12 and y minus x also equals 12, then subtracting the equations shows that x must equal 0. A triangle cannot have a side length of 0, so this case must be rejected. Now pay attention to the important conclusion. We did not find one triangle. We found 3 different integer right triangles that all satisfy the given conditions. The first is 5, 12, 13. The second is 9, 12, 15. And the third is 12, 35, 37. Since all 3 are valid, we now have to calculate the area of each one. Remember that the area of a right triangle equals 1/2 multiplied by the base multiplied by the height. For the 5, 12, 13 triangle, the area is 1/2 multiplied by 5 multiplied by 12, which equals 30 square units. For the 9, 12, 15 triangle, the area is 1/2 multiplied by 9 multiplied by 12, which equals 54 square units. For the 12, 35, 37 triangle, the area is 1/2 multiplied by 12 multiplied by 35. Half of 12 is 6, and 6 multiplied by 35 equals 210 square units. So the possible areas are 30 square units, 54 square units, and 210 square units. This means the information given in the problem is not enough to determine one unique area. There are multiple integer right triangles with a leg of length 12, and each one produces a different area. Therefore, the correct conclusion is that the area cannot be determined uniquely. It could be 30, 54, or 210 square units, depending on which valid triangle we have. If you spotted that there would be more than one possible triangle before we finish the solution, let me know in the comments. And if you found this explanation helpful, make sure to like the video and subscribe for more challenging math problems.